Hello, my name is Willem Alexander. Today I will be presenting on my internship at the Spatial Query Lab. My academic background is that I am a senior in the GIS program at A&M Corpus Christi. I have completed Geospatial Systems 2 and Remote Sensing, which both cover georectification, which is a vital skill that I've used at this job. I completed 2 Esri certifications that dealt with georectification in order to enhance my resume and prepare for the position back when I was applying to it last year. The Spatial Query Lab's mission is to make spatial technology, education, and information accessible to everyone, according to our website. It is coordinated by Brian Gillis. It is located in the Natural Resources Center at A&M Corpus, and it is part of the Conrad Blucher Institute. The SQL lab has got lots of projects floating around. I'm going to go over a few of them here. Cardinal is a survey management software. It basically imposes job sites over Google Maps, and with it, employers can track jobs in the field on the map and track task progress. Weather on Wheels, it's a collaboration with the Coastal Dynamics Lab. There's some folks down the hall from us. It combines route information from Google Maps, so basically navigation from Google Maps with forecasts from the Weather Service, so that as you're calculating your route and planning it, you have weather forecasts, if anything unusual is going to happen along the way. And there is also the Shoreline Digitization Project. It is a partnership with the U.S. Army Corps of Engineers. It focuses on digitizing aerial imagery of the Texas coastline that goes back several decades, and then using georectification to impose those on modern satellite imagery in order to measure the shoreline change in the intervening years. The project that I have been involved with is the map scanning project. The Mary and Jeff Bell Library holds several collections of surveying records, and that's not just maps, it's also field books, it's job folders, it's indices, tying all of it together. The goal of the project is to digitize all of the collections and upload them to where the public can access them at the Texas Digital Library. Map scanning has been completed for Green and Blucher collections. I believe they finished those last summer before I joined, but they're still scanning those other types of documents for those collections. The current main focus of our project is on the map scanning for the Penny Finner collection. Here's a little bit about the Penny Finner collection. The Finners were a family who settled in Beeville, Texas around 1879. That's about 70 or 80 miles northwest of Corpus. They're kind of in between Corpus and Austin. The office of B County Surveyor was the first Finner was elected to it, and it got passed down to his son as they were elected to it. So they've just got a whole block where that family was the county surveyor from 1879 to 1932. Herbert Whalen was a nephew of the last Finner who held the position. I don't really know any more about his relationship other than that, so I don't know if he was from one of the Finner daughters or if he was an in-law. But he succeeded and held the office from 1932 to 1971. And then Joe C. Penny Jr. was, I believe, an apprentice to Whalen. You see him noted as an associate on several maps in the 60s with Whalen's signature and seal. And then he succeeded Whalen in 1971, and from that point, we see a lot of maps that have Penny's signature, but now he's got his own surveyor's seal. Today, he is retired. I don't have a date for that. I couldn't find it on the internet. The collection represents the surveys of these 5 men over a period of more than 100 years, along with some other documents from other surveyors. I'm guessing that those were just passed along and kept in their archives as further reference for the local area. The collection mainly centered on Beeville and B County, but they also did lots of work in the surrounding counties, Live Oak, um, DeWitt. They've gone as far down as Portland. I've seen some thinner maps from that. My position with the team is that I was originally hired in September 2018 for this project. My duties are to scan, catalog, and geo-rectify the Penny Finner map collection. And by the way, I know that in the previous slide, Penny is spelled, with that second E, but the collection names drop that. That's not up to us. The library is the one who named this. And I figure by the time they saw their mistake, it's on way too much paperwork to bother changing. In any case, I do all that, and I have written articles for the SQL blog on the work we do for this project. This here is a picture of our room we expanded this semester. We now have a second room, and this second room is devoted to the map scanner project. We have the scanning station over on this side, and we have a little bank of computers over here that we use for the cataloging and geo-rectifying. And these are some of my other student workers. Well, some of my student co-workers. So the first step in the workflow is scanning. The maps are kept in rolls. In groups of those rolls are the maps are in groups of 10 per roll, and they are transferred from the archives in the library 9 rolls at a time. We pass the maps through the scanner one at a time, and the scans must be free of scan lines and crumpled edges or corners in the final image. The scanned images are saved to a storage drive, which is accessible over our network within the lab, and we assign them an index number that is specific for our database. The next step is cataloging. That's our process of entering the image files into the project database. We have a portal through BandoCat, which is a website that was developed by the computer science part of the SQL lab to meet our needs specifically, and it's being continuously developed on. We use this page to document relevant metadata. What's required, you can see here with the little red asterisks. These are the little points of information that will always be present on the map, and therefore we always have to fill those fields before submission. So they include the library index, the document title, and in case there is not a title, like see here on this example, we have the title down here, but there are sketches and stuff like that without any formal title or such. In that case, we will use the library index as the document title. And then we have to make a judgment on the readability and rectifiability on the map. So readability, how easy it is to read the lines and measurements and whatnot, and rectifiability, how many resources are present on the map, like creeks and named roads and whatnot. That'll make it easier to find where this is, what the map is depicting in the real world, so that we can rectify it, and how many points we think we can find that will make for good rectification. And then the document medium is the type of material the map is made out of. This one right here is a cloth map. But we also have maps made out of paper. We have maps made out of tracings, and we have maps made out of blueprint materials. And anything else we just classify as paper. We've got like some mylar. We just use the paper field. But the other data that we do like to get, but that we don't always have, is the document authors. So you can see this is a Wayland map. We like to get the document start and end date, so any dates on the map, the earliest to the latest. We like to get the map scale. Is map is actually a very relevant question. We do have some documents that are something like architectural drawings that got tossed in with the collection. That's not a map. Um, we have some some papers that are placeholders. They're placeholders for maps. Like they're a document from the library that says this map is in too poor condition to be taken out of the library. This is a placeholder for describing it. So in that case, our document is not a map. Uh, and we have placed to mark down, is there a north arrow? Yes or no. Does it have a street? That has to be a street that is named. There's not, like if there's a road and it's just marked road or a county road, that's not specific enough. We need a street name. Has POI, that's point of interest. That's stuff like creeks or rivers or highways or railroads. Stuff that is highly visible and highly identifiable, like right here, that bendy thing, that's a river or a creek or some such. And has coordinates, that's for maps like quadrangle maps. That makes it really easy to georectify later. If we just have coordinates, we can just plug those in and it'll match up. And whether it has a coast. This hasn't been really relevant for the penny finner collection because we don't, not a lot of our maps depict the coastline, but they're in the older collections, like the Blucher collection was centered on Corpus Christi. Those would have had a lot of coastlines, and this is the same page, the same format as was used for the Blucher collection. So for the next stage of our workflow is georectification, and this has been my main duty. Brian cleared me for georectification last November, and so although I occasionally help out with the other stuff, most of the bulk of my time is spent on georectifying. So after supervisor reviews the catalog document for errors when we're logging the data, they're flagged as available for georectification. So that's what this field back over here is: needs review yes. It's defaults to yes. We have to leave it as yes. And when we upload it, then a supervisor can come through all the documents that have got yes ticked for needs review. They'll look it over. If it's all good, then mark it no, and then it goes down the pipeline to us for georectifying. We use georectification. We use a tool through BandoCat for georectification. We don't use ArcMap. And if the map is able to be rectified, not all of them are for various reasons, the process will result in a KMZ file which can be viewed in Google Earth Pro. So it'll lay itself over Google Earth Pro satellite imagery at its geospatial location. And here is an example of the tool in use. So on the left side here we have Google Maps overlay, I believe, and we can switch between satellite and street view. So right now we use street view mainly when we're hunting down streets and towns, trying to find the general area that a map is located in. And once we've done that, then we switch over to satellite view in order to make matches with the property and such. Stuff that doesn't show up in street view. And also street view doesn't align quite oftentimes with the satellite view. So like the road might be a little bit off. So we're prioritizing matching ourselves with the satellite imagery over the street view. So that's on the left side, and on the right side we have our uploaded document. In this case we've got a depiction of a property adjacent to a town called Papalote. Papalote is just an itty bitty town. A lot of these older maps, this is probably an older Finner one, some of them depict some towns that were, the railroad passed through. They're little boom towns, but as the 1900s wore on. Uh, the economy changed, how people interact with trade changed, and a lot of these places became little ghost towns. So Papalo today just got like a few people around. It's hardly a town. And as you can see here, we've got a street grid here, which no streets here. I was able to resolve this because of the grid here. So that those grids are of property. So although the streets don't exist, those streets still are can be used as approximations of the property line, since the street right of way is usually going to be right in the middle of the border between two properties. So, and I also found this highway here. On the map, this is a railroad. It's an old railroad that got tore up long, long ago. But this is located southeast of Skidmore, Texas, and Skidmore was a big railroad hub. There was basically a big triangle of lines there, branching off north, southwest, and southeast. So I went back up to Skidmore and traced the railroad line back down southeast towards Papalo, and I discovered you can still see like parts of where the railroad used to be. The vegetation hasn't grown back over it yet, and I can see it merging with this highway. And the highway keeps going at the same angle. So this part of the highway that I used as a point is coincident with where that railroad used to be. So you need a minimum of 3 points for georectification. So with that in mind, there's this one street that is still there, and I found this little grid of property. Go 2 grids up, you can still see little property line divisions. Maybe there's a fence, maybe that people just let the vegetation grow there between their properties. You can still get a feeling for where those little properties are. So I was able to match that up, go a couple squares up, use that corner, use this corner, use the intersection with what used to be the railroad there, and I get a pretty good match for what I had, what I had to work with. There's ever so slight warping there, but for what I had, it's pretty good, and it still gives people, somebody can come look this up online and see, oh hey, this is where this goes, this is what this is depicting. So, and you can see how maybe these streets never existed, maybe they did, but if they did, you can see how the town has changed over time, and that's pretty neat. So because of my interest in researching some of the history behind certain aspects of the maps or what they depict, I was offered the chance to write articles for the lab blog, which I'm supposed to focus on interesting maps. I've written about 10 articles for the blog since about November 2018, and 3 of those have been posted. The topics that I've covered so far and what's been posted were a very thorough and accurate city map of Beeville from 1947. So it georectified extremely well, and you could see exactly, all the changes that have happened to the city since 1947. So I thought that was, very interesting, historical view for anybody who comes in and needs that. Another one was that I used a map depicting Meadow Creek as a jumping off point to the Texas Cart War of 1857. And I used a map which I was able to locate its property via a Google search. It was just something I tried and it worked out, and I thought, oh well, that hardly ever happens. So concepts from our classes that I've used at work, I've spent a lot of time talking about georectification. I got a grounding, basic ideas of that from, I believe it was Geospatial Systems 2, and I know for sure we did some of it in remote sensing. I've used some of the surveying experience from field camps sometimes when I'm got a hard map and I'm having difficulties trying to find where it should be. seeing it through the eyes of a surveyor has helped occasionally. And I've used some skills I've developed at reading plats and knowledge of original surveys and boundaries from our legal aspects and history Texas land ownership classes uh, to help with reading these maps. Concepts I wish that class had covered more thoroughly to help prepare for this job better. I mentioned skills at reading historical plats, but I wish, well, plats in general, I wish that we had more practice in reading historical plats, given that a lot of surveying for boundary surveying has to do with historical research. And also construction drawings. We've got some construction drawings, which we count as maps, and that have a different sensibility to the surveyor plats. And I wish that we were shown more, introduced more to resources, online resources, and practice and familiarity with utilizing those online resources for historic information related to surveying. My overall experience at the SQL lab, I developed skills of georectification. Any job that I go to that they ask me if I need they ask the team if anybody skilled georectifying, I'll tell them I'm their man. I've gotten pretty good at puzzling out a lot of these maps, working with limited information and finding where in the world those things belong to, and then of trying to get points for that, and figuring out what will make good points and what will not. And I have learned, some more on my own about reading these historic plats and using online resources for research. Primarily, the GLO GIS viewer. It is basically a miracle. A lot of these maps will mention original surveys, like they'll show along with the modern boundaries where they intersect, or where they're part of these original surveys. And you can go, as long as you know the county that survey is in, you can go to GLO web viewer and type in the county and survey abstract number, and it will it's like Google Maps. It'll show you where in Texas that original survey is, and that's a big shortcut for finding where these maps are. And it was a great work environment. We're all students at A&M Corpus. We're all taking a lot of the same classes, and we keep things pretty light, pretty fun, and we're pretty supportive of each other. So that was my presentation. Thank you for listening.